Good day, I'm Maile Matsiba. Welcome back to our channel. We continue with the class test 1 of 2011 in our CIR 123 module, that is Chemical Engineering 123 module at the University of Pretoria. Earlier, before this video, in the first video, we looked at question 1A, which was saying calculate the excess reactant. So today we are looking at the B part of the question that says calculate the mole fraction of NH3 in the reactor. Now we are given further information here. They say after 1 hour it is found out that 1 kilomole unreacted H2 is left in the reactor. Now for us to understand that better, I made two illustrations here. So remember that before we are told that 1.5 kilomole of we were told that 42 kilograms of nitrogen and 6 kilograms of hydrogen were loaded into a batch reactor, and it was a tight reactor, it was a closed reactor. So when we calculated in the first question, we found that nitrogen or N2 is 1.5 kilomole and H2 is 3 kilomole. Another thing that we can recall in the first video is the fact that we figured out that nitrogen is actually the excess reactant, and also hydrogen is the limiting reactant. So with that said, as we continue here, we're going to then analyze what actually happens, or what happened after 1 hour, and that is going to help us answer the question that says calculate the mole fraction of NH3 in the equation. So the first thing to do is to actually write down the equation of mole fraction of NH3. Now I put it down here. The mole fraction of NH3 is actually the kilomole, that is after 1 hour, the kilomole NH3 that is formed. Let me just write here that is formed, right? The kilomole NH3 that is formed all over the total kilomole in the reactor after 1 hour. So that is actually what we're looking for. And now, for us to get that, we also need to calculate the total or our first or easy approach to answer this question is to calculate the total kilomole in the reactor after 1 hour. And with that said, if we're going to calculate the total kilomole, we know that for full well that we are told that after 1 hour we have 1 kilomole of unreacted H2. So that is the first thing. So the first thing we're going to say kilomole H2, right? Because that's something we are told. Plus, now remember that. Okay, can I explain this? Well, I'll explain that later. Another thing is we had the kilomole excess N2. If we recall in the first video that we did find out that the N2 was actually in excess and the H2 was limiting, which means theoretically we expected all the hydrogen to react and a portion of the nitrogen to remain. Why? Because that portion of nitrogen not having enough of the hydrogen to actually react it. So we expected the hydrogen to be used up. So now we are told that after 1 hour, 1 kilomole of hydrogen is left. This tells us that if 1 kilomole of hydrogen is left, then there's a portion of unreacted nitrogen that is also left. So we can also say plus kilomole unreacted N2, right? Now we have the kilomole, let me say unreacted, so that it can easily be followed. So we have the hydrogen that is unreacted, that is 1 hour, and we also have the nitrogen that should have reacted with this 1 kilomole hydrogen, right? We will calculate that. And we have the kilomole of the excess nitrogen. This one we never expected it to react in the first place, because we found out that it's actually an excess nitrogen, so it didn't have enough, or rather we didn't have enough of the hydrogen to react all of the nitrogen. So we expected this excess nitrogen to actually remain. And then the last one that we have is the NH3 that is formed. Then we had the NH3 that is formed. So for us to make it a little bit easier and also easy to follow, I will just make sure that I break this equation down in parts. We'll start with the kilomole unreacted H2 and put it down. So I'll make a list of those so that by the time we come here, we at least understand where what comes from. See. So we can just say that kilomole unreacted H2. Well, the kilomole unreacted H2, we are told from our statement that after 1 hour we have 1 kilomole unreacted H2. So we know that it's 1 kilomole. And then we have kilomole unreacted N2. Remember that the hydrogen is limiting, so we expected it to react because it had enough of the nitrogen which was in excess, right? But now if 1 kilomole is not reacted and it should have reacted, the question is how much of the nitrogen that should have reacted actually did not react. And we can actually use the 1 kilomole of the 1 kilomole of hydrogen that has left that should have reacted and the chemical equation to actually figure out how much of the nitrogen. And when we look at the equation, we realize that for every 1 mole of nitrogen, there's 3 mole of hydrogen. So that means for every 1 mole of hydrogen, there's going to be 1 divided by 3 of nitrogen. So that means, therefore, kilomole unreacted N2 is going to be 1 kilomole. Let me say 1 kilomole, and let me just make the long root. 1 kilomole H2, right, multiplied by 1 kilomole N2 all over 3 kilomole H2. So that is actually the longer route, but it's the best route because at least everybody can actually follow it. So with that said, we know that the H2 and the H2 actually cancels, so we have 1 kilomole N2 all over 3. That gives us 0.33 kilomole N2. So we know that because 1 kilo out of the 3 kilomole of H2 that we expected to react, 1 kilomole has remained or did not react. The nitrogen that should have reacted with the 1 kilomole, it's actually 0.33 kilomole of the nitrogen. So now we have sorted this one, we have been told, and also we have sorted the kilomole of unreacted N2. Now we need to also go to the axis N2. If you can actually recall, let me say kilomole. Let me just write axis N2. This one we calculated it. We had the values calculated in the very first part, so it's not so difficult. It's actually total kilomole N2 minus theoretically required N2, right? Yeah. So which means the total kilomole of N2, we've calculated it to be 1.5 kilomole. So which means it's 1.5 kilomole minus the theoretically required N2. We calculated it to be 1 kilomole in the first equation. Or you can actually go back to that video and look at it. It's not so difficult. So we have then 1 kilomole of the theoretically required nitrogen. Now this gives us 0.5 kilomole. So now we have managed to sort out the unreacted H2, which we know, and also the excess N2, which we calculated earlier, or we use the values that were calculated earlier, and also the unreacted N2, we managed to calculate it. So now we are left with the NH3 formed. Now, for us to actually get to find out the NH3, let me write it down here. Kilomoles NH3 formed. Let's use the equation. We are told that, remember, the 3 kilomole H2 was actually the theoretically expected to we theoretically expected it to all react, but we are told that 1 kilomole did not react. By extension, that tells us that 2 kilomoles of H2 reacted. And now when we go to the equation, if 2 kilomole of H2 reacted, then we can use the ratio to calculate the number of hydrogen of NH3 that has actually formed. You see, so we can just say is equals to 2 kilomole H2 multiplied by the ratio is 2 kilomole NH3 all over 3 kilomole H2. So I actually used the reaction equation to actually calculate how much that is, because if 2 kilomole of H2 reacted, then you can figure that out. So now with that said, it gives us, because the hydrogen then falls off, yeah, so we are left with 4 over 3 kilomole NH3, and that becomes 1.33 kilomole NH3. Now with that said, let's go back to our equation. Remember, the mole fraction was saying we need the kilomole of NH3 formed all over the total kilomole of all over the total kilomole in the reactor. So now we managed to create an equation to calculate the total kilomole in the reactor after 1 hour. So with that said, we can just say, therefore, total kilomole in the reactor, let's mention that after 1 hour is equals to, let's go to the equation we created, the kilomole unreacted H2, we are told that it's 1 kilomole, so it's 1 kilomole plus the kilomole excess N2. We calculated excess N2. Yeah, here's excess N2 is 0.5 kilomole plus kilomole unreacted nitrogen, unreacted N2. We calculated unreacted N2 to be 0.33 kilomole plus the NH3 that is formed. We just calculated it to be 1.33 kilomole. Now therefore, this equals to, if you mix and if you rather use your calculator to calculate every single thing, you'll find that the total kilomole in the reactor is actually 3.16 kilomole. Therefore, now we're answering the question. Remember, the question says what is the mole fraction NH3? We have all the values, the NH3 formed and the total kilomole. So therefore, mole fraction NH3 is equals to kilomole NH3 formed is 1.33 kilomole all over the total kilomole in the reactor after 1 hour is 3.16 kilomole, and if you use your calculator it gives you 0.42. so that becomes it, and that becomes the answer that actually our B Roman figure 1 is actually asking for, that calculate the mole fraction NH3 in the reactor. So thank you for your time, and there's still parts of the class test 1 that is actually remaining, and I'll keep uploading them in part. Thank you for your time, and I hope to meet you again in our next video.